Hello, welcome to my YouTube channel, Learning Circle. I am Nitik Kumar, and today I am going to take a lecture on real numbers. Okay, our first chapter, real number. So let's start. So first of all, I just want to ask, what is real number? What is real number? Because in order to understand the further learning for this chapter, we need to know its base. So the base is what is real number. So real number is also represented as R. So it is said that real number is defined as the collection of rational and irrational number. It simply means that a set of rational and irrational number is called real number. Example, if someone asks me what is real number, then I will say either it should be rational or irrational. So if I give you example, it should be 2 by 5, root 5, 0.1. See, this is rational. Okay. This is also rational, but this is irrational. So the combination of all, this all falls in the category of real number. Okay. So if I ask what is 1, I will say it is real number. It is as simple as that. Okay. So you came to know what is real number. Okay. So further we will move to this rational number. So in class 8, 7, 6, you would have studied rational number. So I'm going to define it, rational number. Okay. So what is rational number? So I will say it is a number expressed in the form of p by q, where q does not equals to 0. Where q does not equals to 0. It means it should be in the form of p by q. P by q means numerator upon denominator. But the q part, that is the lower part, that is so if I give you example, this would be 2 by 5. This is rational number. This is 1 by 2. Okay. So these all are rational number. But before this, I will have to make a note that P by Q should be in simplest form. P by Q should be in simplest form. Simplest form simply means if you take P and Q, it means they have only common factor 1. It means if P and Q are in simplest form, then I will say HCF of P comma Q is nothing but 1. HCF of P comma Q is nothing but 1. Okay. So from here, I can also say that if HCF of P comma Q is equals to 1, then P and Q are co-prime number. They are co-prime number. So what is co-prime number? So if I give you example, take 2 comma 5 and tell me what is its HCF. If HCF is 1, then 2 and 5 are co-prime number. Okay, 2 and 5 are co-prime number. Okay, if someone tells me, sir, what about 1 comma 4? Then I will say, obviously the HCF is 1. Okay, 1 and 4 are co-prime number. Okay, so you understood what is rational number. Now I will go for irrational number. Irrational number which cannot be represented in the form of P by Q. In the form of P by Q, where Q does not equals to 0. Okay, it simply means irrational numbers are those numbers which are represented, which are not represented. It means cannot be represented in the form of P by Q, where Q does not equals to 0. If I say example, the example is root 3. Okay, so root 3 cannot be represented in P by Q form. So this is irrational number. Pi, pi is pi can't also be represented in the form of P by Q. Okay, so this is also not real number. Someone will say, can say that, sir, root 3 is root 3 by 1. So this is P and this is Q. So it is in the form of P by Q. Then why are you not saying that it is rational or irrational? Then I will say, sir, rational number can be represented in the form of P by Q. But there are certain conditions. First condition is P and Q should be integer. Okay. And second condition is PQ should be co-prime. It simply means here root 3 is not integer. That's why it is not a rational number. Okay. It is irrational number. Clear? Next is, if I ask you what decimal expansion, see, decimal expansion can be of two types. Okay. Either it would terminate or it would non-terminate. Okay. So if I ask 0.2, so this is terminating. It means decimal expansion is being stopped here. Okay. So we can write it as 2 by 10, that is 1 by 5. Okay. So whatever terminating decimals expansion, it can be converted back to rational number. Okay. It means I can say terminating decimal expansion is rational number. Okay. Is rational number means can be converted back. That's it. Can be converted back. Now in this non-terminating part, there would be two types. First type is recurring. Recurring means they are repeating like 0.3333. They are not terminating, but they are recurring. Recurring means they are repeating They are repeating 3 again and again. This is one example. I can give you one more example. Suppose 0.14. I am repeating 1414 again and again. Okay, so this comes in the category of recurring. Okay, and there is another part which is known as non-recurring. Okay, so if this is non-recurring, it means there will be no pattern at all. It will be random value. There would be no pattern at all. So non-terminating but recurring is nothing but rational number. But non-terminating plus non-recurring is irrational number. It simply means if I say rational number decimal expansion, then it would be of two types. Either it would be terminating or non-terminating. But if it is non-terminating, then it would be recurring also. Okay. But in terms of irrational number, they would non-terminate and they will non-recur. Okay. So you got to know what is rational number and irrational number decimal expansion. Okay. So all the best. Let's meet in next session. Till then, please like, subscribe, and comment over my channel, and please share it. Thank you.